the mathematical function behind the maximum size variation is pretty complex, but I don't want to get too much technical. But with these two are pretty much relative to each others. For example, I'm gonna just reduce the size to have a quicker rendering here. As you can see here in the preview, we have some size variation. So a value of 1 generally means that the instances will be half the size, or the instances are 1/2 or twice the size. So here we have, for example, if you have 3 instances, we can have the original size, an instance half, which will be half the size of the original, and the other which will be twice the size of the original, and it's distributed like this. In the other hand, we have if it's 0%, and I hope it will have the result. This will mean that will not have variation at all. Okay, so hope this is gonna be visible. Yeah, it's not really here, but as you can see, we have less variation in size than with a value of 1. So the greater the value, the more you have size variation. Okay, and if you want to stretch or squash your instances in other axes, you can just drop down the keep proportion slider here to like 0, and play with your own settings or your own values, and you have click on populate, and then you have some stretched or squashed bushes. This is depending on your needs. If you can create something odd or bizarre, as you can see here, we have stretching, as you can see, with some bushes here. Okay, pretty good. Now let's move on. Just put the settings to like 1 and 1, sorry, and proportion to like 100. Okay, here we have the direction from the surface with perpendicular or vertical. I just clicked here. I'm gonna explain now, and as you can see, we have no modifications or no modifications. Why? Because we have practically no slope. Okay, this is pretty much visible when working with slope. For example, if you put it like 0, the ecosystem will always grow vertically to that surface. So the slope doesn't really matter in this case, because the instance is gonna always grow vertically. But when you go into like 100%, the instances will always grow perpendicularly to that slope. Okay, so pretty much confusing, but just try with slope terrain and you'll see how does it really work. And here we have the rotation. Okay, so here in the rotation you'll have 2 options: all axis or up axis only. This is the maximum rotation that will be applied to the instances. So for example, if you want to limit this rotation here, you can just click it, for example, like 73, and clicked on populate. You see the rotation of my instances, so I limited it to like 70 degrees, so all my instances will rotate all over 70 degrees around the up axis, which is, I think, here the Z axis. The Z axis as defined in your options here, units and coordinates and word coordinates. Yeah, Y axis up or Z axis up. Here it's Z, so it will rotate around the Z axis. And if I checked all axes and clicked on populate, so all these instances will rotate around the 3 axes. So pretty simple and self-explained, so don't lose time there. And I want to go to the variable scaling, which is more interesting than playing with the rotation, I think. Okay. The variable scaling here works pretty much the same as the density. Let's try with this one. As you can see here, you have this effect here of scaling, where white areas, if I could say, here we have black areas, as you can see here. I just move a bit so you can see here. Do a quick render just to compare. As you can see here, white areas have a bigger size instead of black areas, which have pretty much a lower size here, as you can see. Okay, so depending on your, for example, here you can change the profile. Okay, so this depends on your needs, but just try with some customized map so you can get the concept. I'm really sorry to not give you the all idea of the thing, because my English is a little bit bad. So, but I think you've just got the idea of how it really works, and you can experiment yourself. Now we have the color tab. In the color variation here, we give you the ability to give a certain color to your scene or to your ecosystem. For example, here we are at gray, but if I want sci-fi scene, maybe I want some purple or some pink. Okay, and click on populate again, and you can see that my instances gets this pinkish color here. Okay, so some sci-fi bushes. And here we have also variable color if you want to play with this one. Okay, before going to variable color, I'm gonna just talk about the color allow densities, and here I want then to go back to shrink allow densities. Okay, so this is pretty simple. If you have a map or to control your density, so then the scale will be shrinked allow densities where we don't have much of our population, so it will be shrinked. And here you have the influence radius fall off. So experiment with this. I think you're gonna find yourself, because they are pretty simple and easy to understand. The color is pretty the same thing. Allow densities, we're gonna have a color and the overall color here. Okay, so play with these settings here. I would just go to variable color, which is pretty interesting in some cases. Okay, let's activate variable color. It works pretty much the same as scaling and orientation. If I, for example, loaded a preset like this spiral here, okay, and yeah, like this spiral here, yeah, and then choose a color or I don't know, a gradient like this one, for example, and just click on populate. You'll see how this affects our ecosystem. For example, if I choose another color, it will do the same thing to our ecosystem. And here we have some color variation according to this map. Okay, so like this one here, this one will be very tricky, but you'll see the result. This one here, populate. Okay, so if I choose pretty much something like this, you'll see a better result here. Okay, and as you can see, white areas are more influenced by the color than black area. If I just choose a simple color like this one here and populate, you see that it's pretty much affecting all our scene. I just want to show you how this affects. So play with these, and you have here some nice color variation. Create your own maps. Okay, so for example, if I put you like full black, you'll have a full color. Okay, you have start with white because it's a gradient. For example, here you'll see that it's blue. It starts from there and it goes Okay, so here experiment, as you can see, apply with these settings and try to find how it really works. Like this one here, we have some pixels. Okay, and depending on your density and your scale, if I just drop down scale, maybe you're gonna have something interesting. As you can see here, we have more of the details. Let's try the rainbow colors to see and get the density a little bit higher, and take a look at the image, how it could look like, how it's gonna look like. Yeah, pretty colorful. Pretty colorful, yeah, actually. So driving is pretty good. The functions are pretty interesting and pretty cool. So to drive, for example, these colors here, pop light, as you can see, you have something really like 5 5 5. We have a bigger spiral, as you can see, really good for some specific scenes. I think this is a pretty nice result. Okay, so I think we covered pretty much everything of the ecosystem. So here we have the presence. Okay, the presence here is how much population will be present in your sorry, just drop down. It's pretty much, or it got a little bit of the concept of the density. Okay, so I'm gonna explain a little bit and then we're gonna go further. Okay, here we have the altitude constraint. So how the altitude gonna affect our objects or our instances here, and you have the range of altitudes by object, material, absolute, or relative to sea. For example, if you have sea level, you can adjust this. For example, a high altitude will not find bushes, or will not find some green. Or for example, if you are populating with I don't know, let's take an example of these bushes here. If you're populating a mountain, a snowy mountain, you know, when getting in high altitude you will not find bushes. So you can use this constraint here to delimit, or to how can we say that, to get rid of some instances of bushes in higher altitudes, for example. And slope constraint also works pretty much the same. Here you have the fuzziness and the slope range. So where it will, for example, if you have a flat surface which is between like 0%, for example, you find some bushes, and in a range which is in a range between these two values here, 62 and 12.6, we find if we have a slope between this range, then we're gonna find some bushes, as you can see. Okay, the orientation constraint, also the same thing as slope constraint. They have the orientation, preferred orientation, and the orientation tightness. So these two options here I need to explain a bit. Okay, the preferred orientation, or which it's the orientation which our system or our material, our population prefer. So for example, orientation of 143 degrees will be the preferred orientation of our instances. So if we have so at this orientation, our bushes will be populated. If I explain it in a simpler way, what I could say, for example, when you're watching a TV, you prefer being in front of the TV instead of being at the angles. So this is your favorite position. It's the same thing for this constraint here. So the favorite orientation for our bushes here, and here orientation tightness is pretty much as the influence. Okay, so I think we've covered all these tabs here in there in depth. We have took an in-depth look at these tabs, explaining starting from the general to the presence. We've seen each function, each one of these parameters and settings. So I think you're ready to start creating your own ecosystems. So I just want to talk about dynamic population. Okay, so I don't know if it works, but I'm not creating an infinite plane. Okay, so I'm gonna delete and copy material. Okay, and file. Oops, sorry, what's going on? New default, no. Okay, so here we are, and I'm gonna create an infinite plane or ground, for example, and I'm gonna paste my material. Okay, the ecosystem you are populating covers a huge area, and the viable result will probably be insufficient to perform static population. It is recommended that you use dynamic population instead. Do you want to switch the ecosystem to dynamic population? Yes, I want to, sir. So I'm gonna just move like this and go over there. So here we have our bush, as you can see, and let's do a preview. So now the view, what gonna view do is he gonna populate our terrain according to our camera position, as you can see here. And here he covered all this area, so the visible area, with our ecosystem here. And as you can see, it's pretty well done. And this is the ecosystem, the dynamic ecosystem, so it will always be generated at the angle where you look. For example, if I took my top camera, switch to it and move it up a bit, okay, so, and then selected my infinite planes, right click and do a preview, I will populate ecosystem depending on my view. And as you can see, we just have population where my camera is supposed to look. Okay, so clear. This is the dynamic population. It's pretty good, pretty useful when using huge terrains and we have some low resources. So I think we've covered pretty much everything of the ecosystems, and you're ready to start creating your own ecosystem, your own planet, if I could say, because now you know how to create atmosphere, sea, terrains, ecosystem, just the material part, but we're gonna cover it in the upcoming day. So let's take an exercise just to create something interesting, to just in order to memorize and to understand a bit better the lesson of today. Okay, so reset view and let's get started.